In this segment on measuring segments and angles, we're going to focus on the second part, measuring segments. So our learning goal is that students will understand, of course, how to find the measures of segments and angles. So let's start. Let's jump right in. Alright, so first we're going to start by talking about how to measure segments on a number line. And this first part is a little complex, so let's try to break it down. What we're saying is that the distance between 2 points on the number line is the absolute value of the difference of those numbers on the number line. Of course, remember that difference means to subtract. So, if we had this segment on the number line, segment AB, of course we use this notation to represent the segment. Segment AB, we do the A with the bar, AB with the bar over top. That represents segment AB. But here's a new little piece of notation. If I write AB with no bar on top, that represents the length of the segment. And what we're saying here is that the length of that segment, the length of segment AB, is the absolute value of the difference between those points on the number line, or the absolute value of A minus B. So this is our formula to find length on the number line. You might even want to write a little note in your notes. This represents the length on the number line. Okay? Alright, so let's look at a simple example. Let's find the measure or the length of QS. And this is another important point here. When we're reading this out loud, this little piece here, if it just says QS, what I want you to read is the length of QS. Whoops, that didn't make a Q. QS. So find the length of QS if the coordinate of Q is -3 and the coordinate of S is +21. So here we can see Q is at -3, S is at +21. So remember what our formula said? Our formula said that the length of AB was equal to the absolute value of A minus B. So here we have Q and S, so it's basically the same thing. It's going to be the absolute value of -3, which is the coordinate of Q, minus 21, which is the coordinate of S. So if we simplify this, -3 minus 21 is -24. And then, of course, we take that absolute value. The absolute value of 24 is 24. And let's make some sense out of this. If we visualize our number line here, 0 would probably be, way over here, closer to -3. So there's 3 units between 0 and -3. There's 21 units between 0 and 21, and add those together and we get 24, which is, of course, the length of our segment here. Great. Okay, now when we have segments that are the same length, we say that those segments are congruent. So this is like working with angles that are the same measure. Segments that are the same length are congruent, and we still use our symbol for congruent, the equal sign with a little squiggly on top. So what we're going to see in a diagram might be something like this. Here we have segment AB and we have segment CD, and we can see that there's a length given on each of them. AB is 2 centimeters, CD is 2 centimeters. So here I can make a statement that the length of AB is equal to the length of CD. So this first part is telling me that the lengths are equal. If their lengths are equal, then the segments themselves are congruent. Remember we talked about this? Segments, angles, things are congruent, numbers are equal, and a length is a measure of a number. If your segments are congruent, you're going to be looking for these little marks that you see right here, these little congruent marks or tick marks. Sometimes there'll be one like this, or there could be two, so you could have like 2 here and 2 here. As long as it's the same number on both segments, then we know for sure that those segments are congruent. All right, let's talk about the segment addition postulate. It's a lot like the angle addition postulate, and let's break this down into 2 pieces here. The first part of the postulate says if we have 3 points, A, B, and C, and those 3 points are collinear, and B is between A and C, in other words, B is in the middle, then the length of AB plus the length of BC should equal the length of the whole segment AC. Now let's look at a picture, make sense out of this. A, B, and C are collinear. B is in the middle. So of course it makes sense that if I add the length of AB plus the length of AC, we get the length of the whole darn segment. Of course, that makes perfect sense. Let's do a couple of examples. All right, example 1. If AB is 2 inches and BC is 6 inches, then find AC. Well, if I actually started with the segment addition postulate, I would start with the length of AB plus the length of BC is equal to the length of AC in this picture. So let's fill in the information. The length of AB is 2 inches. The length of BC is 6 inches. So that's going to equal the length of AC. And now let's do the math. 2 plus 6 is 8. So AC is equal to 8 inches. Perfect. All right, let's do another example. Here we have AC is equal to 12 centimeters. BC is equal to 9 centimeters. Let's find the length of AB. All right, I'm going to set it up the same way by starting with the segment addition postulate. Use the actual segments. So the length of AB plus the length of BC is equal to the length of AC. This is how you're going to start your homework. And now let's fill in what we know. We don't know the length of AB. So let's leave that as the length of AB. We do know the length of BC is 9, and we know the length of AC is 12. So AB is my unknown. I'll subtract 9 from both sides. And so that means, of course, that the length of AB is 12 minus 9, or 3 centimeters, because in this problem we were working in centimeters. Great. Okay, so let's look at this last example. If the length of DT is equal to 60, and they didn't give you units this time, then find the value of X. Then find the length of DS and the length of ST. So starting with the segment addition postulate, we know that DS plus ST would equal DT in this problem. So let's fill in the values. The length of DS is 2x minus 8 plus the length of ST is 3x minus 12, and we knew from the beginning of the problem that the length of DT was 60. So we're substituting in those measures. Now let's do our math. Let's combine like terms. 2x plus 3x is 5x. Negative 8 plus negative 12 is negative 20. And then that equals 60. So to solve for x, we will add 20 to both sides. Make sure we do it to both sides here. So we get 5x equals 80. Solve for x, we divide by 5. And of course, 80 divided by 5 is 16. So we look at x equals 16. Have we answered the question? We go up here, well, oh, this part, we found the value of x. Yes, but we still have to find the length of ds and the length of st. And this is a great check because you'll be able to see if you did your work wrong or not. When you plug it in, you should better make sure that your whole segment adds up to a length of 60. So let's do that. We know that the length of ds is equal to 2x minus 8. So that's going to be 2 times 16 minus 8. 2 times 16 is 32, and 32 minus 8 is 24. Now let's look for the length of ST. The length of ST is 3x minus 12. So let's plug in our value of 16 here. So 3 times 16 minus 12. So 3 times 16 is 48. 48 minus 12 is 36. So now what we want to check is, does ds plus st add up to 60, which it should, and it does. So that tells me that I probably did my math right for finding x and for plugging in the values to find the length of ds and st. Alright, so that's it for the notes on segment addition and measuring segments, and we'll practice with this when we get to class. Make sure that you go back, put your questions in on the left. You guys know this, so like for example this one, you're going to draw a little segment here, D, S, and T, and then just write the information. We know that DT equals 60, and then if you can't fit it in your diagram, you could do something like this. ds equals 2x minus 8, and st equals 3x minus 12, like this, something like that. Solve for x. So make sure you get those questions on the left and complete your summaries.